Hi, welcome to the 2021 Virtual Esri Developer Summit, and thank you for attending this technical session, the Introduction to the ArcGIS API for Python. My name is John Yeast, and I'm a product engineer with the API for Python team, and I'll be presenting with my colleague Nicholas Ginner, who's a product manager for the Analytics and Data Science team. And today we're going to provide you with a high-level overview of what the ArcGIS API for Python is and some of its capabilities. The audience we designed this presentation for, we're making some assumptions that you're going to have some experience with using organizations deployed to either ArcGIS Online or ArcGIS Enterprise, and that you also are familiar with Python and its structures and syntax, and that you're here today because you're interested in learning what the API for Python is and what it can do for you. To talk about the agenda in this first part of the session, I just want to let you know that I'm going to cover defining the API for Python, what it is, who it's for, and the architecture of the modules, how you access the API, and both for ArcGIS Pro users and those using the Anaconda distribution to get the ArcGIS API for Python. And I'm going to demonstrate connecting to GIS, showing some of the properties of that, and some basic searching and publishing functionality before turning over the reins to Nick. So what is the ArcGIS API for Python? What it is a Python library based on today's standards, and it's composed of a number of modules that perform GIS visualization and analysis, manage spatial data, and administer WebGIS system tasks. It's designed for and powered by a WebGIS organization, but provides some impactful capabilities on local data as well. It's an API that integrates really well with interactive computing environments like the Python REPL or Jupyter Notebook, but is just as comfortable and powerful in an IDE to create automation scripts. It excels at building these automation workflows for scheduling repetitive tasks, and it provides all the capabilities and functions needed for complete experimentations and conclusions for the data scientist. Before moving forward, when people first meet the API for Python, there are often questions about the difference between Python and the API for Python and ArcPy. Well, let's be clear that the ArcGIS API for Python is designed to script against an organization, either online or enterprise, and is meant to be used with web services and resources in a WebGIS. ArcPy is designed to work primarily with local data in the geoprocessing realm and for repetitive tasks needed for map documents. These are two distinct packages, and that's important to know moving forward. The API for Python was designed with a number of different workers in mind. For administrators, it can provide you everything you need to configure, operate, and maintain various web components like servers and data stores and licenses. And it also allows you to report on item and user and group activity. And for the DevOps professional, everything you need to engineer, program, and test is there in this API. It's a complete library for content publishers who want to add data files and items to the organization and share them however they see fit. And for analysts, it allows everything you need to process and combine imagery and feature data with business assets. And for the data scientist, it's going to allow for everything needed to collect, observe, experiment, and model large and ever-changing volumes of both raster and vector data to produce the information products from these various content. And also for the power user and the developer, there's plenty of capabilities for extending the functionality and building displays in the API. Together, this builds a comprehensive picture of the WebGIS, and the API for Python represents this in a Pythonic way. Within the ArcGIS package, which is what the API for Python is distributed as, the generic GIS module is represented and functionality is organized into a number of different modules, which makes it really simple and easy to understand. Each module has a set of types and functions focused towards one particular aspect of the GIS. The GIS module is the most important and provides your entry point into the GIS, providing manager classes for important items like users, groups, data stores, roles, content, and more. The administrators spend a lot of time in this module and its submodules. These modules in green are used to access the various spatial capabilities and geographic data sets in the GIS, including a complete family of analysis functions, types, and helper objects for working with any kind of spatial data, including the apps module where you can work with certain web applications built with ArcGIS. The modules in blue provide additional functionality for building workflows, including the geoprocessing module, which lets you incorporate third-party geoprocessing tools, and the geometry module for accessing the individual shapes of features and providing data and functions to work with them. And lastly, the modules in orange here provide processing environments and everything you need to visualize and disseminate your GIS data and analysis. The widgets module provides a map widget for display purposes inside the Jupyter Notebook environment, and the mapping module has types and functions for working with web maps, map image layers, and even a submodule for OGC compliant web services. So let's talk about now accessing the API. There's multiple avenues to experience the API, and these are fully documented on the developer's website at developers.arcgis.com/Python. In the guide pages, there's an install and setup guide that talks about the many different avenues of getting the API. But to introduce the API to you here today, we're going to focus on the distribution as a Conda package named ArcGIS. And Conda is a popular package and environment manager application that helps you install and update packages such as the API for Python and its dependencies. It extends the versatility of Python by allowing multiple installations of Python to exist on a single machine independent of one another. Each of these independent installations is called a Conda environment, and each environment has its own set of Python packages. So you can switch between environments without having to deal with separate installations. So I'm going to get into and demonstrate how you access this for two different types of communities. There's the ArcGIS Pro community, which ships with the Conda package, and then the Python geospatial and scientific community who are not using ArcGIS Pro can gain access to this software through the Anaconda distribution. So before getting into demonstrating how exactly to set the API up, I want to talk about the GIS module because I'm going to show this in a couple seconds here. The GIS module in particular contains a GIS class, which is your entry point to the organization you've connected to. It supports all different kinds of login methods, including a pro authentication method that I'm going to demonstrate in a second. It also allows you to create profiles on any local machine where you can then create a profile and demonstrate the software without having to worry about your credentials being exposed. And I'm going to show you a little bit more about what that means in just a second here. I also want to highlight this widgets module that I talked about. It has a map widget that you're going to see here in just a couple minutes where you can display layers on a widget inside this is specific to the Jupyter Notebook environment. So without further ado, let's move forward and see how you get your hands on the API and how it works. For the ArcGIS Pro user, Pro ships with the Conda package management system already installed. So what that means is you already have a Conda environment on your machine and the ArcGIS API for Python is immediately available. Let's see how this works. So if I go over into the analysis window and select the drop down next to Python, I see the notebook and the Python window. If I choose notebook, that opens a new notebook, and I've pre-baked a couple cells in here just to save a little bit of time. And so this is how I import the GIS class I talked about. And then I can assign a variable, and I can use the pro authentication method to use the credentials from the organization that I've already connected to in Pro to access my licensing. So let's go ahead and just run this. I import the GIS class, and then I'm going to make my connection using the Pro authentication. And then I'll show you how you can see what you have access to through that class. So now I've got the class imported, and I'm going to make my connection. And then you can simply type the name of the variable you've set up, a dot, and hit the tab key. And what that does is brings up the properties and methods directly available on that object that you now have in your window. So this gives me access to a number of important things. I've logged in as an admin, so I have access to the admin module here, which then I can choose that and see all my options that are available off that object. And let's take a look at the user's property gives me what's called a user manager. The content property gives me a content manager. And then off each is like press the add the dot, hit tab, and this shows me all the methods available on whatever particular object I'm on. So it's very helpful in using the API to get that information. Let's go over here and just print out some information directly off the GIS class. So I make my connection. If I just hit enter and run the cell that has the variable in there, I see the URL I'm connected to. I can get the portal name, and I can construct the specific URL for my organization using a couple different properties of the GIS. So I mentioned creating a profile. It's very simple. The first time you connect, use the URL to your organization, username, password, use the profile keyword, and enter the name of a profile that makes sense to you. Run it, and then the next time you go to try to connect in a script or a notebook on that machine, you can connect using that profile. So here I'm connecting as this profile that I've called data owner, and I'm going to use the content manager I showed you earlier and the search functionality. Let me demonstrate one other thing real quickly. If I have questions about a particular method, I can use the question mark and run a cell, and then I can get access to the API reference help that gives me the signature of the function and a description of all the parameters and how to use it. So inside the notebook environment, just add a question mark and run the cell, and you've got access to that. So let's do a quick search just using a keyword water and items owned by a particular user. It returns me all the items in that organization of the type feature layer. So there's a quick demonstration of accessing the ArcGIS API for Python inside of a Pro notebook. Let's talk about how you work with the environment, the content environment manager itself. When you go into the Pro backstage and choose Python, what you see is a Python package manager. And this will give you access to and manage all your environments. It will let you create environments, clone existing environments so that you can then update them with packages you want to use. This is where you can control your system. So by default, I mentioned that there's an environment installed with ArcGIS Pro, and it is called ArcGIS Pro Pi 3. And you see here a pathway to where that Python interpreter for that environment is stored. And that's important to take note of because next I'm going to demonstrate how to set up your IDE for automation scripts using a Conda environment. So I've opened up PyCharm here, and if I click New Project, I'm going to create a Python project. I let it default to store the project in a specific location. And here's where I can choose the specific Python interpreter I want to use in this particular project. I'm going to choose the option for previously configured interpreter, and then I'm going to use the ellipses button to navigate to set up this interpreter. I'm going to choose Conda environment because that's the package manager I'm using. Use this second ellipses button to navigate to my file system. And remember, we know where this is from looking at the Pro Python package manager. So in program files, ArcGIS Pro directory, there's a bin directory that then I can navigate into, select Python, and I see an ENVS directory, short for environments. Expand that, and there I see the name of any environment I've created. I'm going to choose the ArcGIS Pro Py3 environment, select Python exe, and choose OK, OK, and let the IDE set itself up for action. Now I'll go ahead and create that. And then we will take a look at how real quickly we can add a Python file to our project. And quickly get some information from the ArcGIS API for Python. So from the ArcGIS package, GIS module, I'm going to import the GIS class. I'm going to set up a variable and use my Pro authentication. And then I'm going to generate a list of all the users in my organization. I use the dot access method to choose the user manager, and then search. And if I just do the wildcard like that, that will search for all the users in my organization. And then let's type just some information about each of our users. Let's get their username. And let's make this print neatly in our output. And let's get the length. Let's see how many items that user owns in their particular root directory. Okay, so let's go ahead and run this script. Let me scroll up so you can see the results of this. Okay, and so there you can see a printout in the console menu of the information I requested. So there's a quick demonstration of how to access the API for Python on ArcGIS Pro and in the PyCharm development environment, and how to use the dot syntax to access the users manager, the content manager, and do some searching. So now let's move over to a non-pro system and use the Anaconda distribution to access the API for Python. On a system that does not have ArcGIS Pro installed, you can navigate to anaconda.org, use the Download Anaconda button to get to the Data Science Toolkit, and download from there the particular Anaconda installer for the system that you're using. So now that we have Anaconda on our system, I can check the names and pathways of the environments I've set up with the conda info-e command. Now I have the default base environment and a number of other environments I've set up. But what I want to show you is how you create your own environment and install the ArcGIS package into it. So you can create an environment, and then when this is done creating, we will activate this environment. And once it's activated, then we can go ahead and install from Esri's Anaconda package channel the ArcGIS package. And that will install the latest release of the ArcGIS package. And so you can see it is in process, and I have already created some environments on this machine that have the ArcGIS package in it. So when I activate one of those environments, once I'm in it, I can type Jupyter Notebook, which will then open for me a web server in the directory where I'm located, and then I can either create notebooks or run existing notebooks from that are inside that directory. So here's what your web server will look like, and I'm in a directory that has a couple folders with some notebooks already in it that I have gone ahead and I've run all the cells. But let's go walk through each of these notebooks and demonstrate a couple quick administration and publishing workflows. So the first thing I do is import libraries, and then I'm connecting using the profile keyword to a specific GIS organization. I'm using the search syntax that we're familiar with on the user manager to generate a list of users. And then I'm using some of Python's built-in libraries to create some time zone information in my local time zone. And then I'm going to write out to a CSV file some information about the users in my organization. So I set up the CSV header with the information I'm looking for, and then go ahead and I set up a directory to where I am so that I can write out that file and then open up that file and see that that's a quick way to print out the information I'm looking for the users in my organization. Another workflow is I connect to a different organization and again, generate a user list. This time I want to take a look at what types of license my users are consuming. So again, I use the user manager object, search for all my users, and then I'm going to go ahead and print some attributes off each user: the username, the role that they've been assigned to, and the user type that the user type license each is consuming. And so I can see that. And then what I also want to do is go ahead and off the user manager, take a look at how many total licenses are available in my organization. And then what I can do is use some Python syntax and the counts variable of the user manager to determine then how many licenses remaining do I have of each user type in my organization. So if I'm doing a create user workflow, I can do some checking, and so that it doesn't error out because the license type's not available. Next, I have some workflows to demonstrate some content publishing. So again, I'm importing libraries and connecting to GIS with our profile. And then I construct some paths to where I have some raw source information and images for thumbnails. And I construct an item properties dictionary. There are some required information that I set up as a Python dictionary, including the type of file that I'm going to add to the system. And then I'm setting up a directory to a thumbnail too for this item. Then I'm going to add the data item, right? Using the GIS, I access the content manager, and I use the add method to add that dictionary I just set up, tell it the path to where the raw source file is, the path to the thumbnail, and the folder in my organization that I want to store it. So I've added this data item and I can see that it's a CSV. Next, I'm going to publish that item directly off that newly added item, publish it, and now I have a feature layer item, feature layer collection item in my org. And I'm going to quickly visualize this layer to ensure it got added. And I can use the map widget and the add layer method to add that new item and see my data. To reiterate that workflow, let's again connect to our GIS, construct paths this time to a shapefile. We set up a similar dictionary of properties and a path to a thumbnail. Then we add the shapefile item to our GIS. And then from that, we can publish that shapefile, see that I have an item, and visualize it. So there we've done a rundown of some quick admin and shapefile workflows, admin and publishing workflows. Now I'm going to turn things over to my colleague, Nick, who's going to do a deeper dive into the API for you.
Okay, thanks, John, for that great overview. So let's briefly go over the agenda for the remainder of this talk. We'll start with a quick review of the different modules of the API. Then we'll see two use cases for several of the different modules where they are used to solve real-world problems. One example will focus on data engineering in ArcGIS Pro, and the second example will perform a site selection analysis using ArcGIS Online notebooks. Then we'll wrap up by taking a look at the documentation website and some resources for further learning. So earlier in the presentation, John gave us a nice overview of the different modules in the ArcGIS Python package, and then focused mainly on the GIS module for administration and publishing workflows. I'm going to do a bit of a deeper dive into several of the modules, particularly the features module, which contains functions for working with spatial data and performing analysis, and the geo-enrichment module, which provides functions for enriching your spatial data with thematic information. One thing to be aware of as we go through is that there are several other sessions at this conference that are dedicated to specific capabilities of the API, such as geoanalytics and big data, geocoding, raster and imagery, building apps, performing network analysis, and then there's also a handful of sessions specifically focusing on the ArcGIS Learn module, which provides tools and functions for performing machine learning and deep learning workflows on spatial data. So now let's move on to some use cases for the API. The background for this first data engineering use case is a recent ArcGIS blog article, which highlights a new spatial statistical tool for comparing two maps with categorical variables. In this case, we're going to be comparing climate zones from one time period to a projection of those climate zones in the future. Notice here that there are several climate categories for each time period. We could download the data from the World Bank. In this case, we'll download a shapefile for each time period climate classification. And we can also open a text file that contains the climate classification scheme linked to a numerical code. So in ArcGIS Pro, let's first have a look at one of the shapefiles that we downloaded. As we can see here, if we open the attribute table, all that we have for our climate zones is an attribute for grid code. And of course, we want the full categories. Recall that I also saved a text file linking the grid code to the climate classification abbreviation. And I've also downloaded a CSV file that links the climate code classification to the full description. So I'm going to need all of these files to continue on. So back in Pro, let's go to our notebook. We'll import our necessary Python packages, including the ArcGIS features module, which contains a class called the GeoAccessor. This class is used when working with the API's spatially enabled data frame, which is essentially a pandas data frame on which you can do all of your traditional data wrangling or data engineering tasks, yet it also has spatial capabilities. It's basically going to allow us to read in spatial data from many different formats, manipulate the rows and columns however we want, and then write it back out to whatever spatial format we want. We'll connect to our WebGIS, we'll create a variable for where our shapefiles are located, and then we'll use the spatial from feature class function to read the shapefile in as a spatially enabled data frame. We can get some information about the spatially enabled data frame. We'll read in our text file. We'll do a little bit of manipulation to our text file such that we have a Python dictionary containing the numeric codes and the classification abbreviations. We could print out that we have 31 different codes to work with. And then we could start our data engineering. In this case, we're going to map this dictionary to the spatial data frame. So what that does is it adds the abbreviation and links it to the grid code from the text file. We can get some more information about the shape of the spatial data frame. We could then read in that CSV file containing the full climate codes information, including the description. Do a little bit of work to replace any column names with spaces to have underscores. Learn that there's 31 rows and 7 columns. And we could then use pandas merge to join the climate description CSV to the spatially enabled data frame. So now we have all of the data that we need to continue on, especially the correct descriptions. We can get the shape and the information about the final spatial data frame. Make sure that we set the geometry column. And this ensures then that the shape field is of a geometry type. And lastly, using that GeoAccessor class, we can write out the final fixed and joined spatial data frame to a feature layer. We'll call this version 2, and we'll click run. So that's run successfully. We now have a feature layer collection in the portal. And note here that rather than writing out that spatial data frame to a feature layer, I could have also written it out to, say, a feature class in a geodatabase or a shapefile. You basically have many different options there. So let's head back to our map. And here we're looking at the climate classifications from the first time period. This layer was already here. But what I could then do is head over to my portal, and we could search for the feature layer we just published, the one that contains the future climate projections. We could add this layer into the map, and then we could see, by opening the attribute table, that all of those fields that we engineered are there. We could then use these fields to symbolize this layer by importing the symbology from the previous layer to this layer. So we'll choose to import the symbology from the previous climate classification layer using the source and target fields that we engineered. We'll run it, and then we should be able to view the change in the climate zones from time 1 to time 2, time 1 to time 2. And to round out the workflow from the blog article, we could run the spatial association between zones tool, specifying our categorical zones for the time 1 and time 2 climate maps to be the description fields that we fixed using our data engineering. And of course, we can then look at the outputs and see that we replicated the workflow. So that demo highlighted the use of particularly the GeoAccessor class from the features module to do some data engineering to prepare data for some additional analysis. In this next demo, we're going to explore several more of the modules of the Python API within the context of an ArcGIS online notebook. Our scenario is a site selection analysis where we are determining the most ideal location for a new gym or fitness center in our franchise. We'll begin by mapping our existing gym locations, and then we'll create 15-minute drive time polygons around each gym location. We'll then enrich these drive time polygons with information related to things like socioeconomic status, lifestyle, and the exercise habits of the surrounding population. We'll then map our existing gym members and summarize the members inside of the drive times to determine which is the best performing gym. We'll then geocode a data set of potential gym locations, create the 15-minute drive times, and then enrich these drive times with the same variables as the existing gym locations. And then we'll use a function to find the potential gym location that is most similar to the best performing existing gym based on those socioeconomic, lifestyle, and exercise characteristics. We'll connect to our WebGIS using my username and password. And then we'll import some non-ArcGIS Python packages, such as ones for manipulating data frames and doing some charting. And then we'll start to add some of our GIS content. One of the really nice features about ArcGIS Online notebooks is that you could search for items via a content browser. This is nice because you don't have to actually type in the Python API syntax for searching for content. So I'm going to search for the term GIMS, and I'll click Add, which will create a new cell in the notebook that allows me to access my content for my GIMS. So I'm going to rename the variable here to GIMS. We'll run the cell. We'll see there that we have our layer. And we can also search for content programmatically via the content property of the GIS object. We can use the query string in the search method to set the criteria for the search based on things, fields such as title, tags for owners, etc. And then we'll call gis.map to use the map widget to create a base map. And then we could add both the GIMS and GIM membership layers to view them on the map. Next, we'll import the features module of the Python API such that we have access to the create drive time areas function, which will allow us to create our 15-minute drive time polygons around each GIM location. And when that finishes running, we can add a new map and add both the GIMS and the 15-minute drive time polygons around them. So in the next part of the workflow, we're going to do the geo-enrichment, which is going to add the thematic information to those 15-minute drive time polygons. So the first thing we'll do is import our geo-enrichment module. It has a class called country. This is going to allow us to see the different data as available for this country. So we'll display the various data topics available for the United States. And that's going to display as a pandas data frame. We should be able to see here that if we scroll down, there are over 17,000 variables available for the United States. And we're going to do a little bit of cleanup here. So we're basically going to go into this data frame and we're going to reduce the data frame down to a much smaller size based on variables that we're interested in, such as income, some tapestry information about lifestyle, and some characteristics about exercise habits. So we've gone from about 17,500 variables down to a pandas data frame of 52. We're then going to create a dictionary from this data frame. We're going to reduce the dictionary to only the variables that matter to us. So it's now down to a list of 4 variables: income, exercise habits, and 2 different tapestry segmentations. We'll convert the dictionary to a pandas data frame, reset the index of the data frame, rename the columns to have a little bit more of a better meaning for us, and then we're going to convert the variable names to a list because a list of analysis variables is what's required for the enrichment tool. So now that we have that list, we're going to import the features module such that we can do the data enrichment. And we'll run the enrich layer function, passing in that list of analysis variables as our variables of interest. With the enrich function complete, I could then convert the enriched drive times layer to a spatially enabled data frame so I could look at the attributes. And then I've just gone through a series of steps here to have a look at the columns, make a copy of the data frame, do a little bit of cleanup, a little bit of that data engineering work to make sure that the data looks good for the additional steps, drop a couple of columns, convert to a dictionary, rename some of the columns, recheck the list, and then I end up with a subset of the final spatially enabled data frame that contains, for each one of my 9 existing GIM locations, what the characteristics are for the income, exercise habits, and tapestry for each of those GIM locations. So now that we've done our work with our existing GIM locations, created the drive times, and done the enrichment, we're going to work with our potential GIM locations, and we're going to do this through geocoding. So we'll import our necessary modules from the Python API for geocoding. And then I'm going to head over to the content browser where I've uploaded a CSV file of potential GIM locations. So let's add this in. We'll execute the cell, and then I'm going to read it in as a pandas data frame. Okay, so here we see that we have an address, city, country, state, and these different columns for our potential gym locations. We'll do a little bit of work to concatenate all those different location columns into one column. And then we're going to add this CSV file as an item to ArcGIS Online, which essentially creates a CSV item in the portal. And we're going to convert the spatial data frame to a feature collection so it's a hosted layer in the portal. With that finished, we could then map out all of our data so far. So you see here we have our existing gym locations and their drive times. We could add in the potential gym locations. And then we could perform the same 15-minute drive times and enrichment on the potential gym locations. And with those steps complete, we can create a new map widget to plot out all the data that we have so far, including the existing gym locations, their 15-minute enriched drive times, and the potential gym locations and their 15-minute drive times. Next, we want to summarize or aggregate our existing gym members within our existing gym 15-minute drive times such that we can get the average membership costs for each existing gym location. We'll import the features analysis module from the Python API such that we can call the summarize within function. In this case, we're summarizing gym members information within 15-minute drive times, and we're making sure that we take the average of the dollars spent for each gym member. We could then convert the summarized data into a spatially enabled data frame, keep only the necessary columns, and then sort the spatially enabled data frame by the total dollars made per gym. So we see here that gym number 9 has the highest average membership costs. And we could then view our results as a bar chart. In the last part of this workflow, we'll import 2 more functions from the ArcGIS.features module. We'll first use find existing locations to query out our best performing existing gym location, that was gym number 9, as a new layer. Then we'll run find similar locations, which identifies the most similar location amongst a set of candidate locations, in this case our potential gym locations, to an input location, in this case our best performing gym, based on a series of attributes, in our case some variables about socioeconomic, lifestyle, and exercise characteristics. And we can display our results on the map where the purple areas are the existing gym locations and their 15-minute drive times. The red polygon is our best performing existing gym location, which is gym number 9. And the darker the potential gym location polygon, the more similar it is to our best performing existing gym location. In this case, it is the Londonderry, New Hampshire location. All right, to wrap things up, let's take a look at the API documentation website and some resources for further learning. In a web browser, let's head to the ArcGIS developers webpage for the ArcGIS API for Python product. I think the best way to learn more is to start with the tutorials, which brings you to the guide. This guide is organized based on capability and includes dozens of API syntax examples. You can learn how to install and update the API. You can learn what's new in the API. And then you could dive into the different capabilities, such as working with the spatially enabled data frame, performing different types of analysis, mapping, visualization, etc. Keep in mind here that each one of these has detailed code snippets and examples that you should be able to apply directly to your work. I also recommend trying out the sample notebooks, of which there are over 100 broken down into different categories and workflows. I can't say enough about how much I've learned personally by going through these. As an example, almost all the syntax I showed for performing the geo-enrichment in the second demo I did was copied directly from the one sample, this one being the Airbnb properties across New York City. I just adjusted it slightly for my data. This is the section here that shows the geo-enrichment workflow. Lastly, remember to check out the API reference, which describes all the syntax in the API broken down by different modules and submodules. So that was a brief overview of the ArcGIS API for Python. Good luck using it, and thanks for tuning in. All right, hi everyone. This is Nick Ginner here, and I'm here with my colleague John Yaste from the Python API team. Thanks for taking the time out of your day to attend our session. We hope you found it useful. There's a lot of great questions that came in the question and answer during the session. So we're going to take the next 15 minutes or so to go through some of the questions live, give you some answers, and then have a little discussion between myself and John. When we're done, just to keep in mind that if there's anything that we don't get to answer, or if there's anything you'd like to talk to in more depth, we'll both be working at the Python, I guess we call it like the island. So that's a good place to get more feedback as you go through the developer summit here. So John, I'll turn it over to you if you want to start rolling through the list.
Okay, hi, and thanks for attending, everybody. And we're just going to roll through the questions that came in and answer as many as we can get to. So one that came in a number of different times was asking whether the notebooks that were used in the presentations will be available. And yes, they will. They will be available at the Python API public repo, which is at github.com/Esri/ArcGIS Python API. There will be a conference talks branch in that repo that all the slides and notebooks will be uploaded to after the conference. And the conference itself makes resources available from the presentations as well. And if you have specific questions about using the repo, ask them at the Python API island. I included the link in the reply to the question here. Another question that came in a number of different times was about the profiles that were demonstrated. So let me explain what the profiles are and where they're stored. When the first time in a notebook or wherever you're using the Python API, you can set up the GIS class with the first time you do it, you set up the URL, you set the username and password, and then you can use a keyword to the GIS class, the parameter called profile. And you set profile equal, and then you create a name of a profile that you want to use. And then you make the connection. And then on that specific machine from that point forward, you no longer have to enter the URL, username, or password when you're making a connection through the GIS class. You can instead just use the profile keyword and use whatever name you gave your profile. That profile is stored in a file called .arcgis profiles, which is a text file in your OS user home directory. And that file stores the URL and the username that you used, and it encrypts the password and stores that credential along with it as well. So those were the two questions that were asked quite a bit. Let's go through and answer a couple more. There's one that says, is the API for Python what one would use to create a custom geoprocessing tool on server, or is ArcPy what is used to create a custom geoprocessing tool on server?
Yep.
Nick, do you want to answer that one?
Sure, I could take that one. So I did do a little bit of text actually in the reply there, but bottom line is that yes, the API for Python, generally it's used to work with WebGIS. I think we saw that, there's a significant number of you who use it for WebGIS from the second poll there. But it can be used inside any custom ArcPy geoprocessing tool as well. Typically, ArcPy is used to build Python toolboxes, but essentially you can use any Python library in ArcPy toolboxes and scripts. So yes, the answer is yes there. Good question.
Okay, yeah, great. Another question, can you use this API to automate publishing by reference services or just hosted? No, you're able to use this to publish a by reference service by using the item.add method and just referencing the URL of the existing service, and that item will be published by reference. So yeah, another good question. Okay, another question. Can you set and change item IDs with this API. Example, for replacing or moving items across environments while retaining its item ID. There is some functionality in the API that would allow you to do that. What you need to look in the API for the group migration manager, and then you can set up a group with item IDs you want to preserve, and that then you can export the items from those group as a package and then import it, and the item IDs are preserved. So the API does have functionality in a class called the Group Migration Manager for that. And if there is a cloning apps and items session tomorrow at 11:30 that goes into detailed use of that Group Migration Manager. So that's a good question as well. I'll respond to that. Okay, so another question. If you have cloned Conda environments in one version of Pro, are they still valid after upgrading to another version of Pro? Say you are at 2.4 and then you upgrade to 2.6. This user envisions the cloned environments would be out of date, but also sees potential for lots of conflicts. To my knowledge, if you upgrade Pro, the environment, the default environment that is shipped with ArcGIS Pro, named ArcGIS Pro Pi 3, has a release of the Python API that is pinned. So if you upgrade to a release of Pro, my understanding is that the default environment would be overwritten with what's there, with what's the default environment for the whatever new release of ArcGIS Pro that you put in there. But that is a good question, and maybe if you address that in the Python island, in the Ask Our Experts, or in the wherever you would ask Pro questions, there might be some more details that they can provide on that. I don't have a ton of experience of knowing what happens when you do that. So so yes, thanks for that question. And then there's another question here. Hi. Can I overwrite a layer that I have in my ArcGIS Online from a CSV file? How can I do that? Or if I need to append data to a hosted feature layer from a CSV, you can. There is an explicit append function in the API that allows you to update feature layers with data from CSV. There's also at the Python guide pages at developers.arcgis.com/python/guide. There is an appending guide that goes through a number of examples of how to append data from a CSV. And you can also, there's an overwrite parameter on the publish call, which allows you to do that as well. So thank you for that question. Okay, so we have a question I think was real pertinent to this on comparing the API for Python to ArcPy. Does the API cover everything from ArcPy? So Nick, I'll start with this and then turn it. No, it doesn't. These are two fundamentally different APIs designed for different purposes. The API for Python is designed to work with your WebGIS system, whether it's an enterprise organization or an ArcGIS Online organization. So the API is geared towards the web system and the request response system of WebGIS. There is some crossover in functionality and analytical functions, but the API for Python provides a whole slew of administrative capabilities for the WebGIS that are non-existent in ArcPy. Nick, do you have anything to add on to that?
Yeah, I would just sort of echo what you said. Again, I think the big difference is that the API for Python again focuses on the WebGIS and especially the consumption of feature layers and feature sets, and rather than the kind of locally stored shape files and geodatabase feature classes and so forth. Where I find that there's most overlap is just in some of the analytical functionality. So for example, like you can make a buffer in both. There's some in fact, the entire workflow that I showed in that second notebook, which was that sort of customer store site selection for gyms, I actually built all that stuff in Pro a long time ago and did a demo in Pro using all ArcGIS geoprocessing tools. And then I replicated it all in the sort of WebGIS notebook environment using the Python API. So yes, analytically speaking, but they do, um, they do have their own strengths. I guess just to kind of morph that into another question that came up, I believe the question was, can you use ArcPy in notebooks? And yes, you can. You can use ArcPy in Pro notebooks, which is like what I showed you in the first demo. And then if you're using notebooks in Enterprise or online, there's a runtime. So basically, there's two different runtimes. There's a standard runtime, which is a whole bunch of open source Python libraries, and the Python API, which is what this talk was about. Then there's an advanced runtime, which is a whole bunch of open source Python libraries, the Python API, and ArcPy. So, there are some real complex, spatial data science problems that might involve you using the ArcGIS API for Python alongside ArcPy. And you can do that based on runtimes in online or enterprise notebooks, and you could do that in Pro.
Yeah, great. Thanks, Nick. On to another question that says, before running geo-enrichment or drive time geocoding, can we run a function to show how many credits will be consumed? You can. There is an estimate parameter in the methods. So if you're in the Python API, any of the methods that may consume credits, you will see there is an estimate parameter in there. And if you set that to true, it should provide you of an output that estimates how many credits will be used. So there is that functionality available.
And there's also really good documentation. Well, it doesn't give you an estimate based on your exact work that you're doing, but in the ArcGIS Online documentation, if you just Google ArcGIS Online credits, there's an entire documentation page that tells you what different functionality costs in terms of credits. So you can at least do a rough estimate. A couple of hundred credits per this thing, you could figure out how many of this thing you have to do and then do that multiplication. So that's a way to do it as well. John, do you mind if we just quickly walk through a couple of the quick archived ones?
No, go right ahead. Yeah.
Okay. So a couple of other questions that came up that I think will be relevant. Somebody, anonymous, asked, can you schedule a script to run at regular intervals and store credentials anonymously in the script? And yes, the answer is yes. And I think the solution here would be in ArcGIS notebooks, there's functionality called scheduling. And so what that allows you to do is to write a notebook, have it execute end to end, and you could schedule it to run at regular intervals, like maybe once every day, once every week, once every couple of weeks, once every couple of months. And that's actually functionality that's in notebooks and enterprise, and it's functionality that will be in notebooks and online in about a week from now when the new version of ArcGIS Online comes out. So the ability to schedule these scripts is available, and it's very helpful, as well as storing credentials anonymously in the script. When you schedule these notebooks, there's an option to use something called parameters, which essentially could allow you to inject a parameter into a notebook in a place where maybe you have to type in a username and password. And you could type that username and password sort of before running the notebook as this parameter. And then once the notebook executes, that information is hidden behind this parameter, so you actually can store the credentials anonymously. We addressed, is it possible to use ArcPy in notebooks? Which version is notebooks integrated in Enterprise and Pro? So you have to have Pro 2.5 or more recent to use notebooks in Pro, and you have to use Enterprise 10.7.1, or I'm sorry, 10.7 or more recent to use notebooks in Enterprise. And if you have ArcGIS Online now, they're available there. I guess
Nick, I was just going to say, I think our session is about to end in a minute or so, and just one question is in there. The latest release of the API is 1.8.5, which was just released last week. And one other question, do you have to create a custom role if you're logged into ArcGIS Online Accountant Pro? And the answer to that is no. You do not have to create a custom role. So I just want to make sure that everyone knows about the Python island at the Ask Our Experts section of the Dev Summit. So if any of your questions didn't need to get addressed here, please stop there and make sure to ask them there.
Yeah,
Nick,
and thanks for coming to the session, and thanks for asking good questions, and enjoy the rest of the Dev Summit.